In class activity 9A, we look at writing expressions for dot, star, and stick designs. So this is where we need to remember our meaning of multiplication, and we want to make sure that we can put each one of our terms and describe a certain portion of each one of the designs. So we look at this flower design. We've got 3 different designs. The first thing we want to do is look at the structure of the design. We've got 1 green center, we have 6 purple circles, and then we have 4 outer petals. Each one of these designs has a different number of dots in each one of the different sections of the flower. So you can start in the center and move out, or you can start with the petals and move in. But the first thing we want to do is we want to find the total number of dots in each one of these designs. So the first design, we have 1 dot in the center. Then we have the 6 purple circles, and there's 5 dots in each one of those. And then we have the 4 petals, and there's 3 dots in each one of those. Now, some of you may be used to writing this with a different times operation symbol, but it's the same thing. The thing that we do need to focus on is the meaning of multiplication. This tells us, the order that this is in tells us we have 6 groups of 5. And this tells us we have 4 groups of 3. If we were to draw this a different way, 1 plus 5 times 6 plus 3 times 4, this expression would not represent this design, because it says maybe the 1 is okay, but this tells us we have 5 groups of 6 dots, which we do not have. And it also tells us we have 3 groups of 4 dots, which we do not have. So we have to be very, very careful about the way we order our factors in this case. So let's take a look at this next expression. Again, I'm going to start in the middle, and there are 4 dots in the middle. So I'm going to start with 4 plus 6 groups of 3 plus 4 groups of 6. Again, need to make sure we have 6 purple circles with 3 in each one, and 4 petals with 6 in each one. Now, you could put these in any different order as long as these expressions right here stay the same. All right, so let's look at design C. We still have 2 in the center. Then we have 6 purple dots with 4 dots in each one. And then we have 4 petals with 5 dots in each one. So writing a numeric expression is just as simple as that. You look at what they're asking you to do. In this case, they want an expression that involves both multiplication and addition. So not just addition and not just multiplication, but both multiplication and addition. And look at the patterns and make sure that your actual expression is in the right order in terms of groups and how many in each group. So let's look at this next example. It says write 2 different expressions for the total number of dots in the dot design below. You might want to stop the video and challenge yourself to find 2 different expressions for this dot pattern. In this problem, we're not told that we need to use addition and multiplication, so we're left to do whatever we want to do. So you could do something where you looked at each one of these rows. So we've got 1 plus 3 plus 5 plus 7 plus 9 plus 11 plus 9 plus 7 plus 5 plus 3 plus 1. That's a perfectly good numeric expression to tell me what number of dots are in this picture. And I would, to explain this, say, well, I have 1 dot in the first row, 3 dots in the second row, but I might start to see some different patterns going on here. But even just looking at this expression right here, I can start to see there's a way I could simplify this. I could write an expression that's 2 times 1 plus 3 plus 5 plus 7 plus 9, and then plus 11. And then I would have to justify where I'm getting that. So here's my 1, 3, 5, 7, and 9. So there's my 1, 3, 5, 7, and 9. And here is the other part of that. And then this green right in here is my 11. So I have 2 groups of 1 plus 3 plus 5 plus 7 plus 9 plus 11. How else could we do this? So we could look at this another way. We could take and make this a rectangle. So that would be 3 groups of 9, and then we would have these 2 extra dots on the end. So we're going to make that plus 2 times 1. So we don't want to put plus 2, we want 2 groups of 1, plus, then let's look at the remaining triangle. We've got here, and the remaining 2 orange triangles gives us 2 times 16. So we're going to end up with a total of 27 plus 2 plus 32, which gives us 61. So let's go over here and check over here. This is 2 times 25, which is 50, plus 11, 61 dots. So no matter how we break it up, we just want to make sure that our expression, we can clearly show how our expression relates to our picture. Let's try an even more interesting one. Can you see how we could also draw this as 6 times 6 plus 5 times 5? Take a minute and stop the video to see if you can figure it out. Okay, let's take a look at this more closely. In each one of these diagonal rows here, I've got 1, 2, 3, 4, 5, 6 dots. And every other row has 6 dots. So that gives me 6 groups of 6. Now I have to go back and take a look at the dots that are in between. Well, each of these individual rows in between have 5 dots. So I've got 1, 2, 3, 4, 5 rows of 5. So 5 groups of 5. Let's check to make sure it's evaluated to the same number. So let's go back to here. So this is 36 plus 25, which gives us a total number of 61 dots. We can also use different operations besides just addition and multiplication. If you look at this expression right here, can you tell me how you would see this as 10 squared minus 4 times 2? So let's take a look at this. We've got 10 dots this way and 10 dots this way. So the number of dots in this expression is 10 squared. But we're missing, so 10 squared, but we're missing this amount of dots in here. So we can actually take away 4 groups of 2, because if we were actually looking at the number of dots that were in here, let's make them yellow dots. And so go 1, 2, 3, 4, 5, 6, 7, 8. So we've got 4 groups of 2 dots. So we're going to actually subtract those to get this space in the middle. This will represent 4 groups of 2 dots. Of course, we could do this an entirely different way. If we took and divided this into different parts, and we could then write this as 3 groups of 10 plus 4 groups of 4 plus 4 groups of 4 plus 3 groups of 10. Or we could just say that we have 2 times 3 groups of 10 and 2 times 4 groups of 4. To explain your connection between your numerical expression and your picture, one of the things you could do is shade. So here's our 4 groups of 4, and then here is our 3 groups of 10. And you can see there's 2 times 3 groups of 10 and 2 times 4 groups of 4. So no matter how we write these expressions, we should get the same answer. So for example, this is going to be 100 minus 8. So we'll end up with 92. And this will give us 2 times 3 times 10, so that's 60, plus 2 times 16, which is 32, so 92 as well.